Hey, we're back. Section 8.2. This is part 2. Probability. It's nighttime. Anyways, probability of events. We previously discussed calculating probabilities and simple probabilities and the equally likely assumption. And none of that has changed. That's all still applicable. What I am going to talk a little bit more about is how do you actually go about calculating probabilities. And then I'm going to go through a bunch of examples. So let's do it. So first of all, how do we determine the probability of an event? Sorry, of an event. There's a couple of steps that we use. But if the event is an empty set, then the probability is 0. So if the probability that you are going to, in 2 dice, is what's the probability you're going to roll 25? It doesn't exist. It's not in the set. It's not in the sample space. Therefore, the probability is 0. So it is the empty set. If the event is a simple event, then we assign the probability as we did above. So probability of rolling a 12 is 1 over 36. If it's a compound event, then it's the sum of the simple events. The probability of rolling a 12 or a number greater than 11. So that would be two of the events 11. So there's 2 of those, and then there's one that's 12. So that would be 1 over 36 plus 2 over 36, which is 3 over 36. Should I write these? Yeah, I'll write them. We'll do it on here. That's what this paper's for, right? So the probability of rolling a 12. This is from the dice. This is from using this dice chart. We have that the sample space is equal to 36. So the probability of rolling a 12 in 2 dice. There's 1 probability. So there's 1 chance of that, so it's 1 over 36. Of rolling a number greater than or equal to 11. If we look at this chart, we'll see that we can get a 12 or we can get 11 twice. So that would be 2 over 36 plus 1 over 36, which equals 3 over 36. And that is how we do the simple events. That's how we do the simple events, which is the 1 over 36 with the compound event, which is the 3 over 36. If it's asking a question that is, what is the probability of rolling a number less than 20? Well, that's the whole sample space. And the probability of an event in the sample space is 1. If it's not in the sample space, it's an empty set and it's 0. If it is the sample space, it's equal to 1. What are the steps that we go for doing this? Well, the first thing we do is we determine the sample space and the size of the sample space. And then we look at the event space and we determine the event and the size of the event, and then we assign probabilities to the simple events. And the simple events are part of the sample space. And then we add simple event probabilities to determine our compound probability. I've got a couple of examples here. I'm going to leave these examples up, and then I'm just going to go ahead and write them down on the side chart here. And we're also going to use this to give us a little bit of a clue of what we're working with. Okay. So, given 2 dice, this is our 2 dice chart. What is the probability of rolling an even number? So we're going to do even number. Well, first of all, we have to know what the sample space is. Let's take a look. What we're supposed to do this in order. Determine the sample space. Well, the sample space is this chart, and there's 36 entries on it. So n of s is equal to 36. Then we determine our events. Well, and assign simple probabilities to our events. Well, the probability for a simple event, so the probability for a simple event, is equal to 1 over 36. In other words, each one of these has a probability of 1 over 36. So each one of these is a separate simple event. Okay. And that's why previously, when we determined the probability of 12, it was just 1 over 36. Now, what's the probability of an even number? Well, if you want, we can go ahead and count them. And we can count them from the chart. I'm okay with that. But in this case, even is half of the numbers. So I'm also okay with saying that the number that are even is equal to 36 divided by 2, which equals 18. So the probability of even is equal to 18 divided by 36, which is equal to 1/2. Okay. There's more to that question. The next part of that is, what is a prime number? And sure, we'll go ahead and we'll answer what is a prime number. I'm totally fine with that. But honestly, let's do a couple others first. And if need to, we can reference this chart. So let's say, well, we did the probability of greater than 11, and we did even. So the probability that the first roll, probability that roll 1 equals 6. Now we can use the chart, and we can look at, if you notice, there's a listing 6-1, 6-2, 6-3, so we can certainly look at that. But we can also think to ourselves, well, roll 1. What is the sample space of roll 1? The sample space of roll 1 is 6. There's 6 possibilities, and 6 is one of the possibilities. So it's kind of a faster way to get there. You can do it from this other chart, in which case you'll end up with 6 divided by 36. Now, we have that, the probability, well, let's do probability of a prime. That's what we have in our question, so let's do that. What's the probability that it's a prime? Okay. Well, the first part of this is, how many events are prime? What is a prime number? So the first thing to do, let's figure out what our prime numbers are. Going from 1 to 12, 1 is not, 2 is, 3 is, 4 is not, 5, 6 no, 7, 8, 9, 10, 11. So these are primes. These are our prime numbers. Now, how many times do these occur in our table? They don't occur at the same rate. So there's 1. There's 1 over 36 for this one. Plus, for the number 3, there's 2 over 36. For 5, there's 1, 2, 3, 4. For 7, 1, 2, 3, 4, 5, 6. For 11, there's 2 again. Prime equals the sum, which is 10, 14, 15. 15 over 36. We could also literally just look at our table and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I must have missed one. 1, 2, oh, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sorry if that was off the page a little bit, but you can also go through it and count specifically from this chart, and you'll end up with 15 over 36 as well. Should I do more from there? I'll do one more. I'll do another one on here. So I'll do two more actually. So, and this kind of previews going into unions, complements, because this is kind of the complement idea. So if I want to say what is the probability of not 12, well, we could count up all of them, and we could say it's all but one. So it's 35 over 36, right? But there's another way to get there. It's all but 1. So it's 1 minus 1 over 36. These are, can't see it. These two numbers are exactly the same, which equals 35 over 6. So now, using the complement method, what's the probability that it's not prime? Again, we could go to our table and literally count them out, or we could use information that we currently have and say it's 1 minus 15 over 36, which is equal to 21 over 36. And that's often the faster method to do. Let's take a look at the question that we have that says a circular spinner is divided into 15 sectors of equal area. So let's kind of draw a little sketch of what we have here, right? It's not going to be super accurate. It's a spinner, so it's got a spin thing on it, and it's divided into 15 sectors. I don't know. I think that's 15. That are the equal size. So that what that's trying to tell us is that the probability of landing on any one of them is exactly the same. And then we have that 15 of them, no, 6 of them are red, 5 are blue, 3 are yellow, and 1 is green. It wants to know what the sample space is. And I'll be honest with you, there's 2 ways you could write this sample space. You could write it out as, and probably the best way is to write it as red, 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 6 of them, red, blue, 5 of them, three yellow, and 1 green. And if we do this, we'll have the size of this is equal to 15, which matches up, and this is probably the better way to do it. You can also do it as I did it in the example, but then you have to note that the sample space is 15 and that there's a different probability assigned to each one. So the simple events are the probability of E is equal to red. Probability of the event is equal to red is equal to the number of red, which is 6, divided by 15. Probability of E is equal to blue is 5 over 15. Probability of E is equal to yellow is 3 over 15, and the probability it's green is equal to 1 over 15. Now, if we sum these up, so if we were to sum these, we'll note 6 plus 5, 11, 14, 15 is equal to 15 over 15, which equals 1. And that's a good way to double check that you're doing it properly. So when you have a sample space and you're enumerating, listing every single simple probability in that sample space, you shouldn't end up with a sum is equal to 1. That ends our lecture for this evening. The next set we'll talk about unions, intersections, and complements. Thank you.